Hi, in this video we'll do two questions about electrical stuff relating it to the circular motion. So you may want to try question 37 and 30 by yourself first. So pause the video now.
A few moments later.
This question should give you some height because finally there are some questions that is not giving you numbers but giving you variables, and then you can try to derive stuff, and this is the core of physics really, and I hope you enjoy it. And so first of all, you should know that here is a negative charge, here is a positive charge, and one very important assumption that we have is this positive charge is fixed at that point. Alright, it doesn't move at all. And that will be similar to the case where when you have in the gravitation, where we sometimes will say, oh, there's a big mass and there's a small mass that would be orbiting around this big mass. Okay, so the big mass is not going to be influenced by the small mass. So in this case, the physics framework will be very easy. However, if both of them are inferential to each other, of course they should be free to move in any cases. But then let's say if the mass of these two are kind of close together, then each of them will be affecting each other significantly. And in astronomy, we will have something similar to this we call binary star. So you may want to check it out and Google it if you are interested. Alright, so here are some animation of how it may be moving. So obviously the physics behind will be more complicated than what we are going to do here. Anyway, let's start with part A. So it asks you to draw the force of the moving charge. So obviously they will attract to each other. So this is an attractive force towards the center, and it is always pointing towards the center. That's why it's performing a circular motion. And so for part B, it wants you to derive this equation for the velocity. So obviously what we are going to do is we'll be using what we learned in chapter 6, and so starting with F equals ma and apply it with circular motion. And so for the force, it will simply be the Coulomb's law, which is K Q1 Q2 over R squared. Here I took away the negative because that actually tells us the direction. But then in our case, we already know the direction is pointing towards the center, so we don't have to include the negative here. Okay, and then we'll have M, and then A will be the centripetal acceleration, which give you 4 different forms that you can choose if you recall what you learned in chapter 6. And here, if you look at what they want you to do with V squared, then obviously we should do V squared over R. And so first of all, I guess you would want to cancel the R on each side, and then we try to rearrange it, so then V squared will be the main term, and then keeping Q square and K on the other side, and then M will be moved to other side, so that will be MR. And if you try to compare yours with the answer, that basically is the answer already, because K by definition is 4 pi epsilon here, Q square over MR, so exactly like what they have. Now we can try part C. So for part C, it asks you about the total energy, and in fact this whole thing is exactly the same as what you do in gravitation. So if you know how you can derive those things, like the total energy of the orbit in gravitation, then you should know this as well, because it's again exactly the same. So for the total energy, it will be the sum of the potential energy and kinetic energy. And so that would simply, by recalling the equation for potential energy, that would be K Q1 Q2. Again, this time you will have the negative because we don't have to account for the direction, but then we have to account for the sign, and then R plus the kinetic energy, which is 1 over 2 mv squared. But then here we got the v squared, so if you allow me, I'll just copy the answer from part 1 and then square it directly. Oh, when I try to move on to the next, I find I make a careless mistake. There shouldn't be a square here because this is already v squared. Yeah, sorry about that. So simply this term. Okay, and so now it should make sense. We just try to check each term. I think we should get q squared first. So we have q squared and q squared here, and then we have the r remaining, r and r remaining. Okay, so I think in your case you shouldn't be circling it. All right, I just try to show it to you, and then the m actually cancel out, and that makes sense because there's no m here. So what you have at the end is simply k here, and then this actually is also k, but then you have half. So you have negative 1k and then positive half the k. So eventually you have negative half of k, right? Like this. And so again, as you know, k should be at the top. And then eventually you know that it's going to be 2 times 4, because again k is 4 pi epsilon inverse, so 8 pi epsilon. And yeah, so again exactly like what we have here. Part D is very obvious, because originally now it is at the radius of r and change it to 2r, and so you just have to use the equation that you derived in part C, and so that will simply be the delta E, because it asks you the energy required, right, or the energy that you need to supply. So now you have this one, and then later on you have another total energy. So finding out the difference between them can tell you the energy you need to supply. So we will be using the new one, or maybe we should say E2 minus E1 in this case, or E2R minus E1R. So in fact, it is simply having all these taken out if you want to. And then you have 1 over 2R minus 1 over 1R. Or you can even see these as, because they both have R, you can also take it out as well. And so this is like 0.5 minus 1. So that will be negative 0.5. So negative 0.5, that means you have the negative cancel out. You have q squared at the top, and you still have half at the bottom, so 16 will be the coefficient eventually. Oops, I almost forget the r. So yeah, that should be the final answer. Question 38. So when you see this question, you'll find out this is related to the previous one, and now everything is so sensible because they tell you this is actually a model of the hydrogen atom. If you remember, hydrogen atom should have only one proton, being the simplest kind of element. They only have one proton, there's no neutron in the nucleus, and so positive Q would be a good way to say, versus the electron, the only one electron is negative Q. So this is a good approximation of the model itself. So part A asks you to derive this equation, something to do with T, the period, square. And so obviously, I guess you just have to use a similar approach that we did in the previous question, because I think when you try to look at right hand side, it looks like the force as well. So I will start with F equals to ma again. As for force will be K, Q, well this time it actually should be E, because it's at negative E, and then in the atom then it would also be positive E, so E square in that case, and then we have R square at the bottom, so like K, Q1, Q2 over R square, and then M, and then for centripetal acceleration this time we shouldn't be using V square over R, because if you look at what you are trying to derive. And so when you look at the data table, then we should be using 4 pi square R over T square. Yeah, this one. Okay, so that should give you the T square, and that will come very handy. And so we just have to rearrange it, and I believe everything will just be in place. yeah, everything's just in place if you just try to check every single term. So I will simply be rearranging the form that they did, and that should be how you can do it. Part B would start to be more about the algebra, like substitution, so not as that exciting as what you did earlier. But then let's go through it simply. So they ask you, what if the radius is that much? Calculate the period. So simply, you have the equation and substitute everything, I believe. You have, of course, you know pi. Mass you can find in the data booklet, which is, again, here, 9.11 times 10 to the power of negative 31 kg over k, and for k you can find it here, or if you can remember it, that would be great, times 10 to the power of 9, I believe, yes, 9. Okay, and then for E is the elementary charge, which you can find here, 1.6. So knowing how to use your data table, or data booklet I should say, is very important. Okay, don't forget square here. And then R is the one that they give, which is 0.5 times 10 to the power of negative 10 cube. Okay, so simply substituting everything and press it on your calculator, you should find the answer. Alright, so if you do it properly, you should find t squared. Okay, just provide you the number so that you can check if you did anything wrong. Times 10 to the power of negative 32, and then after you wrote it, obviously, will be the actual final answer. Will be something like this, 10 to the power of negative 16, and so you should run it to maybe 1.4 negative 16 in the unit of second. Part C is the same as part D in the previous question actually, but this time they give you the number simply. So you just have to do the same thing. So delta E equals to E of the 2, this radius, minus E when this is 0.5. Alright, just a notation that I made up. And so again, I would recommend you to take this out, which you should have negative E squared over 8 pi epsilon naught, or we can do 2k simply, right? Because you can just find k directly, you don't have to press that many buttons. And then you would have 1 over 2 times 10 to the negative 10 minus this one, which is 0.5, the original one. Okay, the opposite of the original one. And that should give you the answer. And again, you can see that they both have the term 10 to the power of negative 10. You can take it out. And then when you try to look at 1 over 2 minus 1 over 0.5, it's actually negative 3 over 2. So the negative will kind of cancel with the negative outside, become positive 3 over 2. And then you have everything else. So E square k over 2 times 10 to the power of negative 10. Again, E you can find from the data booklet as well as the K2. Alright, so eventually you should find the answer as something like this, 10 to the power of negative 18 joule. And if you like, you can just run it.